Okay, welcome to 4.5. And what we see here, rational functions, again, that's just dealing with fractions and fractions and equations. So equations that have fractions in them, we're going to graph them, and we've been talking about these all along. So these guidelines are very good for us to understand some things. And this part over here, horizontal assumptions, these are for your horizontal asymptotes. You need to memorize these three. Now, I'll talk about them in an easier way. This is just the formal way of explaining those three things. So it's pretty simple what each of these things mean, and I'll talk about them as we get to it. And then the guidelines over here on the left, we've already been doing this. So you find your x-intercepts, you want to find the real zeros, then you find your y-axis, y-intercept, and those can be done in any order. And then number 4 is what we're talking about over here. So we'll get to number 4 here in a minute. And then it just gives you these other guidelines to follow. So let's get into some simple things for graphing. Okay, so it's asking us to do quite a few things, but really the main thing of this lesson is I want us to be able to graph this stuff. And you do need to be able to do parts B and C. So let's get started here. Whenever you have a variable in your denominator, it's going to be pretty simple to do the graph of these. So let's go ahead and plot just a few points so we understand what to do, and you'll have to plot a few points eventually. So x can't be 0. So right off the bat, I'm going to do our asymptotes in yellow dotted lines, or let's do blue. It's a little easier to see. Blue dotted lines. So x can't be 0. So when x equals 0, that's a vertical asymptote. Now that's usually the 5th or 6th step, but we're going to start with that because we're plotting a few points. Something that's obvious here. Now, there are no other zeros here. And you're like, oh, so that means we probably are going to be able to cross the graph somewhere, but not always is the case. Sometimes you're above the x-axis and never cross it. But what I want to tell you is what will make y equals 0, okay? So if we say y is 0, what happens? Can y be 0? If we multiply both sides times x, all of a sudden x disappears and you have 0 equals 4, and that doesn't work. Okay, so that means when y is 0, we have a horizontal asymptote. Okay, so we'll put one right here. All right, and the next thing is, since the asymptotes are both the x and the y-axis, technically you can cross them in the middle somewhere, but the end behavior of your graphs approaches these things. So we still need to plot a few points. So let's plug in 1 for x, and we get 4. We plug in 10 for x over here. 4 over 10 is 4/10, so it's way down here for y. What's happening is the end behavior is coming from the y-axis and going and coming closer to the x-axis, but never touching it. What about -1? If we plug -1, we get -4. And how about -10? We get -4/10. And it looks just like this. Now I want to talk about the asymptotes, how we can easily see what they are. Anytime you have it like this, whatever's in this position is your y asymptote. And again, if that's all you have, then y equals 0 is your horizontal asymptote. And then whatever's in your denominator is your vertical asymptote. Whatever makes your denominator go to 0. So that's how you get your horizontal and vertical asymptotes on a simple fraction like this. Let's move on so we can talk about x-intercepts and y-intercepts again. Almost forgot. We got to do parts B and C. So part B here is find the domain. So domain is everything on the x-axis. So if we squish everything to the x-axis, it's going to be negative infinity to when x equals 0. Remember, it's all the x values that we're talking about. And it can't be 0, so it has to be a parentheses. And then from 0 to positive infinity. So if you push everything down to the x-axis, everything's going to be shaded in except for the 0 area. Okay, and then if you do range, this is domain range, Again, squish everything over to the y-axis. Okay, everything will be shaded except for the 0 area. So again, that's going to be the same thing, negative infinity to 0. And here you're talking about the y values, and then from 0 to positive infinity. And then part C, find the intervals where it increases and decreases. Okay, well, it increases, you can just use I. Increases, let's do decreases it's first. Decreasing from negative infinity to 0. Again, it's the x values. Everything is the x values except for when you're finding range. So now let's do increasing. And you're like, oh wait, we're not increasing here. After 0, it's still decreasing. So it's decreasing again. So really what we need to do is union from 0 to positive infinity. It's decreasing this way and it's decreasing that way. Decreasing meaning the y value is getting smaller. Okay, so nothing is increasing on this graph. Okay, now use the graph to complete the statements. As x goes to negative infinity. So what's happening is here is it's asking what happens on the graph as we go left. And again, this is your y value. What's happening to the y value? It's decreasing. It's going to what value? It's going to the y equals negative 2. Okay? So y is going to negative 2. And as x goes to positive infinity, as x goes to the right, y is going to negative 2 as well. All right? Then, as x approaches 3 from the left, 3 from the left, so this position right here. As we are, let me just get rid of these lines. As we are approaching 3, as x approaches 3, what is happening to y? Y is going to positive infinity. Y is going up. And as we approach 3 from the right side, as we approach from this side, what is happening to the y value? It's going to negative infinity. And as x approaches 0, so let's erase some of this stuff here. As x approaches 0, and we always go to 0 from the left, what happens to y? As x goes to 0, y goes to what? Y goes up to 0. Okay? All right. It increases to 0. Use arrow notation. Okay. So to describe the end behavior of the function. All right. So first of all, do we even know what this looks like? Oops. Let me just show you a graph. You don't have to graph this. Let me show you the graph of this. Again, this is a simple graph. There's no horizontal asymptote over here. It's plus 0. So your horizontal asymptote is the y-axis. And we're going to change that as we progress here. But for these types of simple fractions, when there's just a number in the numerator, y equals 0 is your horizontal asymptote. But also look at this right here. Instead of do this in blue. What makes your denominator 0? When x is 3. So when x is 3, we have a vertical asymptote. All right. So now, those are our asymptotes. The question is, where is our graph? Well, what happens when we're left of x equals 3? Let's plug in 0. Let's get our y-intercept, right? When x is 0, you have 2 over 0 minus 3, or negative 2/3. When x is 0, we're at negative 2/3, which is about right there. Okay? So that means our graph at the moment is doing this. Okay, well, let's check when x is 1, 2, 3. When x is 4. 2 over 4 minus 3. That's 2. When x is 4, we're at 2. That means the graph is between these two lines. So that's what our graph looks like. And sometimes you just have to graph it. So arrow notation. So as x goes to 3, f of x, y, goes to negative infinity. As x goes to positive infinity, all right, f of x, y, as x goes to positive infinity, y is going to 0. Y is approaching 0. So have we covered all the end behaviors? Okay, really it's wanting you to do some other things. As x goes to negative infinity, what's happening to y? So let's do all ends. So there's 4 ends to these lines. One going to the left and down, and one going to the right and up. So we really need 4 of these. As x goes to negative infinity, y approaches 0. As x goes to, we've already done positive infinity, as x approaches 3 from the right, and really we should have said 3 from the left up there. As x approaches 3 from the right, what's y doing? It's going to positive infinity. And b. Now, whenever you have an x in your numerator, that's when things start to change. Don't say your horizontal asymptote's at 0. Don't do that. It still may be at 0, but don't assume it. All right? So let's get rid of that and let's start our process. First, let's find all our intercepts. How do you find the y-intercept? The y-intercept is always when x is 0. So plug 0 in for all your x's. 2 times 0 and 0 minus 3. What do you get? You get 0, don't you? Okay, so our y-intercept is at 0. Let's go ahead and plot this. It doesn't say to graph it, but it's important to start to get better at this. Okay, so I didn't put this line on there very well. Let's move this up just a little here. Okay, so you're at your intercept's at 0, so that means that's one of your x-intercepts too. You could have more than one intercept. Okay, so how do we get our x-intercepts? Okay, x-intercepts are when y is 0. Okay, what is going to make that go to 0? A fraction go to 0. And this is the easiest one. Well, all you got to do is look at your numerator, 2x. If your numerator is 0, then the whole thing is 0. So what makes your numerator go to 0 is if x is 0. So those are your only intercepts at the moment, okay? So we start with these. This is building up to where you can start doing this faster. So obviously, if you're really good at this, you just keep moving on faster. Just fast forward through all of this. So that's our x and y intercepts. So now let's talk about our vertical asymptote, okay? So what is our vertical asymptote? Well, we set our denominator equal to 0. What makes the denominator go to 0? Because we can't have that value. So when x is 3, we can't have 3 for x. So 1, 2, 3, we have a vertical asymptote here. Okay? Now, how do we find our horizontal asymptote? And here's where it comes back to the beginning of our the video. There's 3 types. So if you look at the exponents on your x's in the numerator and in the denominator, if they are the same, if those exponents are the same, then the leading coefficients is what your horizontal asymptote is going to be. So 2 over 1. So our horizontal asymptote, put it down here, horizontal asymptote is going to be y equals 2 over 1. Vertical is x equals, and horizontal is y equals. So these are lines, x equals and y equals 2. So let's put a horizontal asymptote at y equals 2. So since I know this point is down here, we are assuming at the moment that this is going to look like this. And since there are no x-intercepts to the right of x equals 3, then we can assume that the line is above that horizontal asymptote. All right, so describing the end behavior again, it's the same type of thing as what we did over here. And we'll go ahead and do the arrow notation real quickly here. So what we're doing is we're looking at the x-axis as it goes left or right. Okay, so as x is going to negative infinity, y is going to 2. Okay, and as x goes the other direction, and it's going to approach x equals 3 from the left, then you say y is going, arrow notation, y is going to negative infinity, it's going down. Okay, and then after x equals 3, what's happening as x approaches 3 from the right on the positive side. So y is going to positive infinity. And then as x goes to positive infinity, y goes to gets closer and closer to 2. Okay, let's go faster. All right, now identify any vertical asymptotes and horizontal asymptotes. Okay, again, vertical asymptotes are everything that makes your denominator 0. Okay, and your x-intercepts, you set your numerator equal to 0. Okay, so we don't want the x-intercepts here. We just want the vertical and horizontal asymptotes. All right, and we'll talk about holes at another time. So let's first talk about the vertical asymptotes. Those are the easy ones. So when x is 3 and 6, those are vertical asymptotes. So it doesn't say to graph, but I'm going to just do it because this is really what the whole purpose of this lesson is, to start putting more and more stuff together in an easy way. So I'm just going to graph it so we have a visual of this stuff. X equals 3, 1, 2, 3. There's a vertical asymptote, and 6, 4, 5, 6. There is our 2 vertical asymptotes there. And now horizontal asymptotes. Remember what I said, if you have an x in your numerator, then it's one of 3 types. So what is the leading exponent in the numerator? If you multiply that out, you would get a negative 2x squared whatever afterwards. So x squared would be the top exponent. And on the bottom, if you put those together, you would get x squared. And so one of the things I said is if your exponents are the same, it is the leading coefficients. So my horizontal asymptote is y equals negative 2 over 1, or negative 2. So at y equals negative 2, we put a horizontal line. Okay, so now the question is, that it asks for vertical asymptotes and horizontal asymptotes. So that would be the answer there, these 2 things, all right? So again, graphing everything, let's just look at a couple things. As far as y-intercept and x-intercept, you could plot a few points. I'll get into that when we actually graph the whole thing. But typically, you're looking above and below the horizontal lines to see where you're going to be drawing, and it'll let you know that. So let's move on to other things, and we'll eventually get to those. All right, asymptotes, intercepts. Here we go. Asymptotes and intercepts and holes of a rational function. All right, so notice we have a hole right there at negative 2 thirds. All right, it says sketch a graph of f and find an equation for f. So now we got to find the equation here. So let's sketch the graph first. And first thing you should notice is you have an x-intercept at negative 3, a y-intercept at negative 6. All right, so that means the line is below the horizontal line here. And, sorry, that should be connected there. Go through here, there's a hole at that spot and coming down. All right, so that's that line. And there are no x-intercepts here, so that means the line has to be above that, the horizontal line there. So visually, that's what it looks like. So that's the sketch of the graph. That's the first thing you have to notice on every time you graph is look at your x-intercepts and y-intercepts, and that'll tell you where to draw your lines. Next, we have asymptotes. So what we have here is x equals 1, so x minus 1 is going to be in your denominator. That's the only vertical asymptote. Horizontal asymptote, you have it at y equals 2, which means if we say 2x on the top, the exponents are the same, so the leading coefficients must be your horizontal asymptote, so 2 over 1. So y equals 2 would be your horizontal asymptote. Okay, so the next thing is, well, how do they get negative 6 for the y-intercept? So the y-intercept is when x is 0. So if we just put 0 in for x right now, you'd get 0 in the numerator, and that would mean y is 0 when x is 0. So we have to add something else to the top And if we said plus 6 here, all right, and then we put 0 in for x, you would end up with y equals, of course, then you have 2 times 0 plus 6. I'll just write it out. 1 times 0 minus 1. All right, so then that's 0 plus 6 over 0 minus 1, or negative 6, which is where we have that. So we've made it in a way where all the x's go away, leaving just the y-intercept. All right, so far so good. This is what we have. Okay, so the next thing we need to do here is understand that there's a 0 at negative 2, okay, when x is negative 2. What that means is if you put another value on the top and the bottom, a 0 on the top and the bottom, that'll give you the 0 you need. Okay, so if we do 2x plus 6 over an x minus 1, but then we need a negative 2 in the top and the bottom as zeros. Notice that you'll still have a leading 2x squared and an x squared on the bottom, so it's still a horizontal asymptote of 2. If you set x equals a 0, you still get a 6 times a 2 on the top and a negative 1 times a 2. That's 12 over negative 2, which is still negative 6. So nothing has changed. But to find a 0, that's what you need. All right, and you also still have to check everything else, okay? All right, so let's move on. Now we sketch the graph of this. Notice that there's no x in the numerator, so that means, right off the bat, that you have a horizontal asymptote at y equals 0, okay? And you have a vertical asymptote at 4, so we're going to put one at 4. All right, and now let's find your y-intercept. Or y-intercept is when x is 0. When x is 0, so plug 0 in for x, and you get negative 3/4. So 0, negative 3/4. That's our y-intercept. Our x-intercept is when the numerator is set equal to 0. Okay, so obviously there's no x in your numerator, and that's why we have an asymptote at y equals 0. So it's not going to cross the x-axis at the moment. Technically it can, but at the moment we're just going to say it's not. So since we have a point underneath as we go from negative infinity to positive infinity, we have a point below the x-axis here, so that means we're going to do this and come down. And since our asymptote's on the x-axis, we need to know if we're up here or down here somewhere. So we got to plot a point. So this is at 4. Let's do 5. When x is 5, I get 5 minus 4 is 1. I get positive 3. So that tells me that we are above the asymptote there. All right, so that's the graph. So as we do this, pick up on the little tips to make this work right fast. This one, now we do have an x in the numerator. So let's start with the simple stuff. Y-intercept, when x is 0. We get a 0 in your numerator, and that makes it 0. Okay, and that's also your x-intercept. So x-intercept, what you're supposed to do is set the top equal to 0, and obviously we get 0. Okay, and then let's do a vertical asymptote. Vertical asymptote is when you set your denominator equal to 0. So x is negative 2. So we have a vertical asymptote at negative 2. And horizontal asymptote is you look at your exponents and they're the same. So y equals negative 3 over 1 or negative 3. All right, and that will change. So far they've been equal. At the moment, let's graph what we have. So we have a point above the horizontal asymptote there. So that's that part. But we need to find something either over here or over here. So we got to plot a point. So this is negative 2. Let's go to negative 3 or negative 4. It doesn't matter. Negative 4. If you plug negative 4 in for x, what do you get? Negative 3 times negative 4 is 12 over negative 4 plus 2 is negative 2. That's negative 6. Negative 4, negative 6. All right, so oops, that's down here somewhere. The point is you know where to draw your graph. All right, moving on. Again, our leading exponents are the same. I'm just checking that stuff out. So again, we should be getting faster. Y-intercept, plug 0 in for x, and we get negative 1 over 3. So 0, negative 1/3. And x-intercept, set your numerator equal to 0 and solve. So 4x equals 1, x equals 1/4. Okay, so right there. Vertical asymptotes, set your denominator equal to 0 and solve. So x equals negative 3/2. So we can go ahead and do a vertical asymptote at negative 3/2. That's between negative 1 and negative 2. Oops. Just in between there. Doesn't have to be great. And now the horizontal asymptote, the exponents are the same, so it's y equals 4 over 2 or 2. And so now we draw it. We see that we have these points here. So it approaches the asymptotes, the end behavior. And there are no x-intercepts here, so that means that the line has to be above the horizontal asymptote there. Again, just try to get faster if you can. So let's start before we even draw it. Oops. The y-intercept when x is 0. Plug zeros in for all of that. We get negative 1 times negative 2, 3 times a negative 2. So negative 1/6. All right, so let's start plotting everything. Y is negative 1/6. Okay, x-intercept. Set your numerator equal to 0. So what are our zeros in our numerator? That'd be 1/4 and 2. 1/4 and 2. Okay, very interesting here. So now vertical asymptotes. Set your denominator equal to 0. So what are our zeros? Negative 3/2 and positive 2. Negative 3/2, just like the last one, is between negative 1 and negative 2. And positive 2. So notice that should be a whole. There's 0 in your numerator and your denominator being the same. So that's a whole where we have our x-intercept at 2. Okay. So you don't have to draw an asymptote, but this should show you, I'm going to erase that, that you have a hole there. All right, now horizontal asymptote. Our leading exponent would be 4x squared over 2x squared. So since they're the same, y equals 2 is your horizontal asymptote. All right, so now we're going to graph this. There are no x-intercepts here, so that's going to, oops, let's do black. This is going to go like that. No x-intercepts here at the moment from what we can tell. Okay, so at this 0 here, it doesn't mean that that's a hole at the x-intercept. There is a hole there, but we're talking about a hole on the line. So this is doing this piece right here, all right? And so it's coming from that asymptote, and then it has to cross where x is positive 2. That means the hole is around that position, and then it keeps going and approaches that asymptote. So what has happened is, let me make this a little bit bigger here. This really is an up above, and if you plot a point, you could tell. So it's very important to keep track of what your hole is, and that helps you understand that you don't need to have x-intercepts and still be below that horizontal line. All right, so let's keep going. All right, so what we should do here is simplify before we begin. That's x minus 3x plus 2. Okay, so let's begin. Y-intercept is when x is 0, so plug 0 in for all your x's, and you get a negative 2 on the top, and negative 3 times 2 on the bottom. So positive 1/3 is your y-intercept. Okay, so we're going to draw y equals 1/3 for an intercept. X-intercept is when y is 0, meaning when your numerator is 0, so that's at 2. When x is 2, you get 0 in your numerator. Okay, and now we do vertical asymptotes. that'd be your denominator zeros at 3 and negative 2. So at 3 and negative 2, those are your vertical asymptotes. And then the horizontal asymptote, now we have something different. We have an x to the first on the top and an x squared on the bottom. So when they are like this, when the top one is smaller than the bottom one, then it is y equals 0. Okay, so let's do this in blue. And you say, wait a second, we have an intercept at x equals 2. How can there be an asymptote there? Remember, you can go through an asymptote. It's the end behavior that you have to be aware of. So there, we don't know if, on the left side here if we're over here or down here. So we got to plot a point. So let's put in negative 4 into our equation. If we plug negative 4 into our equation, so now we're graphing. I do use the original equation. Negative 4 minus 2 is negative 6 all over. Negative 4 squared is 16 minus a negative 4 minus 6. So 16 plus 4 is 20. 20 minus 6 is 14. Positive 14. So that's going to be negative. That's all I care about, positive or negative. So that means I'm down here. Now, since I'm above the horizontal asymptote at y equals 1/3, that means I'm doing this. Going over, and I hit that, and I come down. And then the question is, am I above or below over here? So let's plug in positive 4 and see what we get. Again, 4 minus 2 is 2 at this point. 4 squared is 16, minus 4 minus 6. And you have 2 over 16 minus 4 is 12. 12 minus 6 is still 6. That's positive. So that means we're above that horizontal asymptote. And that's what this would look like. Okay, so I just want to point out, you can go through your asymptotes. It's in the middle somewhere that you can cross them. But then it's the end behavior that never crosses. All right, next. All right, so notice we have no x's in your numerator. So y equals 0 is going to be your horizontal asymptote. Just to point out something, in the denominator, your leading exponent is going to be x squared. In the numerator, you still have an x, it's just x to the 0. So the numerator is less than the denominator like the last problem. So y equals 0 right off the bat, I see is going to be my horizontal asymptote. All right, so let's start with everything else again. The y-intercept. Plug in 0 for x, and not that x. Okay, let's get rid of that. Don't want you to think that that's there. Okay. 0 minus 2 is negative 2, but you're squaring it. So negative 2 squared is positive 4. So negative 4 over positive 4 is negative 1. So we have a y-intercept at negative 1, and x-intercept we don't have because it has the asymptote. That's the horizontal asymptote. Vertical asymptote is going to be at 2. Those are your zeros. At 2. Make it blue. Okay. And then your horizontal asymptote we already did, so now we have this because the point is underneath the horizontal asymptote. And the question is, are we above or below over here? So let's plot a point. Let's put 3 in. So we have negative 4 over negative 3 minus 2. Whatever you do, it's going to be positive because you're squaring it. So you have a negative over a positive, which is negative. So we're going to be down here. Oh, didn't see that one coming, did you? And notice I put a negative 3 in there. It doesn't matter. I was trying to say positive 3. It doesn't matter. You're still going to get a positive when you square it. So a negative over a positive is still negative. So that's what that's going to look like. Let's go on to the next. Okay. We'll just start with everything in general the way we do. Y-intercept. When x is 0, I get negative 3 over negative 1 or 3. All right, so let's plot that. And this is how you're going to do it from now on. All right, 0, 0, 3. And the x-intercept, set your numerator equal to 0, or your zeros of your numerator would be 3. All right, and then your vertical asymptote, your denominator set equal to 0. So x squared minus 1 is the same thing as x minus 1, x plus 1. That's the difference of squares. So 1 and negative 1 are your vertical asymptotes. It's a very skinny point right there. We don't have any holes. Remember, the top and the bottom zeros have to be the same for there to be holes. So something's weird about this one. Let's do the horizontal asymptote. So you look at your leading exponents. The top one's smaller than the bottom one, so that means y equals 0, the x-axis. And there's a hole right there. That's going to have to go through that x-intercept right there. So again, on the left side here, in the second and the third quadrants, where are we? We got to plot a point, so let's plug in -2. All right, so if we plug in -2 for x, that's -5 over -2 squared is 4, 4 minus 1 is 3. So that's negative. So I know this is going to go like this, okay? Now what's happening in the middle here? If you were to plot this, you're not crossing the x-axis here. You would have x-intercepts listed. So that means this is going to be doing something like this. It has to be above the x-axis. Okay, now what's happening over here? Right off the bat, I'm guessing this is going to do this. All right, so the only way to know if you're going up or maybe you're going down and then approaching that way, the only way you know that is if you plot a couple points. So I'm going to pick a point over here somewhere. So I'll put 10 in, positive 10. 10 minus 3 is 7. 10 squared is 100 minus 1. That's still positive. Positive over positive is positive. So I know I'm above the horizontal asymptote for the end behavior. And I also know I got to cross the x-axis. So that tells me that I'm going from here up and through the x-axis and then back down, curling back down to hit that part. And if you have your graphing calculators, you can put this stuff in and it'll show you these things. Otherwise, you have to put in like -1/2 and +1/2 and see where those values are. But we could do a +1/2 just to find if we're positive or negative. We don't need to calculate it. So 1/2 minus 3 is negative, and 1/2 squared is positive 1/4. 1/4 minus 1 is still negative, and that makes a positive value. So I know I'm above at that point. So in order to cross a horizontal asymptote that's on the x-axis, there has to be an x-intercept, and there weren't any there, so I knew it was going to be above. And the more of these you do, the better you are. That's why we're doing so many of these. Okay, start with the y-intercept. Plug 0 in for all your x's, you get -4 over -12, which is positive 1/3. Positive 1/3, x-intercept. So when y is 0, set your numerator equal to 0. So let's find all our zeros. Let's factor this. We can factor out a 2, and we get x squared minus x minus 2, which is the same as x minus 2x plus 1. In the denominator, we have x plus 4x minus 3. Okay, so no duplicates there, so no holes. So our x-intercept would be at 2 and -1. Okay, so now vertical asymptotes are next. Your zeros of your denominators would be -4 and positive 3. So -4, positive 3. So all of our points are in the middle there. And our horizontal asymptote would be, we have the same exponents, so our leading coefficients, y equals 2. Okay, so in the middle here, this part seems kind of intuitive. Oops, didn't mean to make it weird like that. Let's do it again. I hope if I draw it correctly. All right, something like that. And now what's happening? You'd have no x-intercepts here, no weird things, so it has to be above that. There's no x-intercepts here, so it has to be above that horizontal asymptote. All right, keep going. All right, y-intercept. We're going to just keep going faster and faster. Try this on your own. Plug 0 in for x, and you get 6 over -4, which is -3/2. You need to try these on your own, or you will fail miserably on the test. 0, -3 halves. That's my y-intercept. X-intercept is when my numerator is 0. So let's factor out a negative. And then let's go ahead and redo that. And we get x plus 3x minus 2. Okay, so our x-intercepts are at -3 and 2. Okay, and our y-intercept, or excuse me, our denominator is going to be x plus 4x minus 1. Again, no duplicates for wholes. So we go to vertical asymptote, would be -4 and +1. And our horizontal asymptote, they are the same exponents, so -1 over +1, so y equals -1. Okay, so again, there are no x-intercepts here. This is going to be down here. And I forgot there's another x-intercept here, -3, right there. Okay, so this is weird. We have an x-intercept above that horizontal asymptote and a y-intercept below it within these two vertical asymptotes. So what that means is it's going to cross the horizontal asymptote to go from here to there, okay, and approach that horizontal asymptote, or excuse me, vertical asymptotes. So somewhere in there, you have to cross it to get to both of those, okay? You're not going to have two lines that go like this, okay? That's not going to happen, because then you have duplicate x values, okay? So you have to cross the asymptote at that point in time. And then what we need here is we got to figure out where we are here, okay? And we have an x-intercept at 2 as well. So that means this is going to be at this point. All right, I just forgot to mark those x-intercepts at the beginning. So that's what that looks like. Hopefully that helps. Let's go ahead and do another one. All right. No duplicates, so no holes. Let's just get at it. Y-intercept is at, plug 0 in for all your x's. Don't forget you got a 3 on the top there. You got 3 times a 3 when x is 0. When x is -3 here, or when x is 0, sorry. You got a 3, 3, and a -4. So 9 times -4 is -36. And the denominator, you have 2 and a -1, that's -2. So 18. 18 for your y-intercept. All right, so before I start graphing, let's look at some of these other numbers here. X-intercept, set your numerator equal to 0, and what do you get? So your zeros are at -3 and +4. Okay, and then we have our vertical asymptotes. Your zeros for your denominator are -2 and 1. Horizontal asymptote. On the top, you're going to have you're going to have a 3x squared. And on the bottom, you're going to have x squared. So since they're the same, y equals 3 will be your horizontal asymptote. Okay, so I'm just checking everything else out. Yeah, so we got to have a huge y-intercept of 18. So I don't know what this really is going to look like, so I'm going to draw my x-axis a little bit lower here. 0, 18, so 4, 8, 12, 16, 17, 18. There's my y-intercept. X-intercept at -3, +4. Okay, and my vertical asymptote's at -2. And +1. This is crazy. And horizontal asymptote at y equals 3. Okay, so again, there's no, let's just start, we'll go left to right here. So since we have this point here, we have to be below the horizontal asymptote. There's nothing that says we're going through these asymptotes anywhere. Again, there's no x-intercepts here, so that means everything has to be above that line. So we don't know if that's exactly what that looks like, but it's going to be above the horizontal asymptote. And going to the right of that, we have an x-intercept, so it has to be down here like this. So there's no weird things to look for, no holes, and nothing that looks like we need to cross any asymptotes anywhere. So that's a fairly straightforward line. Okay, so on the top, let's go ahead and simplify here. Let's take out a -2, and we get x squared minus 5x plus 6. And on the bottom, let's take out an x. Okay, on the top, we have x minus 3x minus 2. And on the bottom, we still have this. Okay, so that's simplified. But I want to point out, your leading exponents are the same, so the horizontal asymptote, since we're talking about it right away, is going to be y equals -2 over 1, which is -2. All right, so now, let's do y-intercept. So when x is 0, so look at the beginning, you plug zeros in for everything, you get 0 in your denominator. Okay, so that's pretty crazy. You can't have 0 in your denominator. So when x is 0, okay, that's a vertical asymptote. So you have a 0 for your vertical asymptote and a -1. And the horizontal asymptote we have, let's talk about x-intercepts. This is all kind of out of order just because based on how it looks, it's kind of weird. You can do it in order and still get the same thing. Okay, so for the x-intercept, that means y is 0. So what makes your numerator 0? So that would be at 2 and 3. Okay, now let's go ahead and draw it. So we have horizontal asymptote at -2. Y-intercept, there isn't one, so that means there's a vertical asymptote at 0, which is what we have here, and also at -1. Kind of weird looking, very thin two asymptotes. And our x-intercepts at 2 and 3. Okay. Now, let's see, so as you're doing this, something's got to happen where this is doing this, which doesn't make any sense because the end behavior has to come back down to the asymptote. So that means there has to be another x-intercept somewhere, but there isn't. So the other option is that it goes like this, which means what's happening here? If it went back up, it'd have to have another x-intercept. So it must go through that horizontal asymptote. Very difficult to see, but that must be what happens. And if you're unsure, you can always do an XY chart and just plot a few points, and you'll see that that's what's going to happen. You can always do this. Okay, now the next thing is, what else is going on? See, there are no x-intercepts here, so I'm assuming this goes like this. All right? There's no x-intercept here, but yet this horizontal asymptote is really close to x equals 0. So we don't want to just assume that this is a really thin line that goes like this. It could be up here doing that. So now you have to actually plot a point and see if you're positive or negative. If you're negative, that means there must, and above this horizontal asymptote, there must have been an x-intercept here, but there isn't. So if it says it's negative, that means we're going to draw this thing down here. Okay. Okay, so we have to put something in. So -1/2. If we plug that in on the top, -1/2 squared is +1/2, +1/4 times 2, and -2 is -1/2. Plus 10 times -1/2 is -5, minus 12. That's going to be negative in our numerator. What about the denominator? -1/2 squared is 1/4 plus a -1/2. That's going to be negative. So that's a positive in when x is -1/2. So it is this drawing up here that we want. All right. So a very odd looking thing. Let me just see if I can erase this a little bit. And of course I erased everything. Anyway, so that's what you're looking for when you're drawing this one. All right, we're getting there. Okay, so let's simplify again. X minus 1 on the top, taking x out of the bottom, you get x squared minus 4, which is the difference of squares. So x minus 2, x plus 2. All right, y-intercept. So y-intercept when x is 0, I get a negative 1 in the top. And if that's 0, everything is 0. So x can't be 0. All right, so remember the y-intercept x is 0. So that can't be. That means that you have a vertical asymptote that is the y-axis because you have no y-intercept. Okay, so let's go ahead and do the x-intercept. X-intercept would be the setting the top to 0, so that'd be 1. X-intercept at 1. Vertical asymptote is at your denominator zeros are 0, 2, and negative 2. So 0, 2, negative 2. Okay, and horizontal asymptote. Horizontal asymptote, our leading exponents, the top is smaller than the bottom, so our horizontal asymptote is y equals 0. And notice now you have a hole. It's going through the asymptote at x equals 1. So now we have to plot some points to figure out where we are. So over here, where are we? Let's plug in negative 4. Negative 4 minus 1 is negative 5. Negative 4 cubed is negative 64. Negative 4 times 5 is negative 20. That's a negative over a negative or positive. So this is what that shape is. Now we have to plug in negative 1 and see where we're at. When x is negative 1 minus 1 is negative 2. Negative 1 cubed is negative 1. And 4 times negative 1 is negative 4. So that's going to be a negative over a positive or negative. So we're down here. Okay. And we can't cross the y-axis. There's nothing there. Now the question is what happens between 0 and 2? So let's plug in 1/2. And it's kind of hard. You're going to have to do it. 1/2 minus 1 is negative. 1/2 cubed is 1/8. 4 times 1/2 is 2. So we have a negative over a negative, which is positive. So it's coming down like this. Going to go through the horizontal asymptote and then like that. And then now we need to see where we are over here. Plug in, I'll plug in 4. 4 minus 1 is 3. That's positive. 64 minus 16, that's positive. Positive over positive is positive. So that's what this is going to look like. 35. Y-intercept is going to be when x is 0, which we get 0. X-intercept is at 0, 0. And vertical asymptote, set the denominator equal to 0. X squared plus 1 equals 0. We're going to get imaginary. So x squared equals negative 1. X equals square root of negative 1. So vertical asymptote's imaginary. And horizontal asymptote is your exponents are the same, so y equals negative 3. All right, so let's plot this and see what we get. So let's plot the horizontal asymptote, the x and y intercept. So very odd. Remember, end behavior has to be approaching the asymptote. So the vertical asymptotes, there isn't one, okay, but the end behavior, since we have our x-intercept and y-intercept above this, and we have to approach the end behavior of the asymptote, it must be above, like this, going up, touching it, and coming back down. There's no other way. There's no other x-intercepts, and there's nothing to say that we are down here in this negative area. And if we were, we'd have to cross the y-axis here, so we can't be there. So this is the only way that this would have to be. And if you use your graphing calculator, I think it'll show you this. All right, moving on. Oblique asymptote, that just means a slanted asymptote, and I'll show you how to do that. All right, So x-intercept or y-intercept, we'll do that first. Y-intercept, when x is 0, we get negative 6 over 1 or negative 6. So negative 6, x-intercept, your zeros of your numerator. So that is x minus 3, x plus 2 factored. So your zeros are 3 and negative 2. So 1, 2, 3, and negative 2. Now, vertical asymptote, it'd be negative 1, makes your denominator equal to 0. Horizontal asymptote, and this is what I was talking about. The top is now bigger than the bottom one, so we have to do long division. So we're going to do x squared minus x minus 6 and x plus 1. So x squared divided by x is just x. So we multiply that through and we get x squared plus x. Subtract, we get minus 2x. Drop down to minus 6. What times, let's see, the first divided by the first there, so negative 2x divided by x is negative 2. And you can stop there. It should be slope-intercept form. So we go through at negative 2, our y-intercept's at negative 2, and going up 1 and over 1. Now, let's erase that negative 2 because it's a hole. This is a slanted asymptote, which is something you can't see. All right, so it goes up 1 and over 1, up 1, over 1, up 1, over 1. So this is a dotted line. It looks like this. Okay, that's a slanted asymptote. So how do horizontal asymptote or vertical asymptotes at negative 1? So we have everything listed. So right off the bat, I see from where these points are, this is our line approaching your asymptote, and the same thing here. There's no other way it could be anywhere else based on those points. Moving on. All right, our last one. So we have negative x. This is the difference of cubes. So you have 8. Just erase that. You have 2 minus x. Take the cube root. Square the first. Square the last. It's a minus sign, so that goes first. Everything else is pluses. And multiply the 2 together, 2x. Okay, and on the bottom, we still have 2x squared. So our leading exponents, just for horizontal asymptotes, the top is bigger than the bottom, so we're going to have to go ahead and do long division. I know I'm getting ahead of myself, so negative x cubed plus 0x squared plus 0x plus 8. So negative x cubed divided by 2x squared is going to be negative 1/2 times x. And so that's going to be our slope. So negative 1/2 x times that is going to be a positive x cubed. All right, and we subtract, negative x cubed, we subtract, you change it. Drop down the next one, 0, 0, 0, okay. So we have 8. Nothing goes into 8. 8 divided by 2x squared doesn't work. So we have negative 1/2 x is our slope of our line, or slanted asymptote. So what is our y-intercept when x is 0? You get 0 in your denominator. So that means when x is 0, that's a vertical asymptote, which we have that right here. And then x-intercept is what makes your numerator 0 when x is 2. Okay, so we have a vertical asymptote at 2 and at 0. Excuse me, that's not right. It's not a vertical asymptote, it's a intercept at 2. Going too fast. All right, now our slanted asymptote goes through at 0 and is down 1 and over 2. Down 1 and over 2. So it's slanted this way. Okay, so what we have on the right side here is this. That's obvious. And there are no x-intercepts over here yet. We said find your zeros in your numerator for x-intercepts. Well, we didn't do this trinomial, so you have to do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a is 1 and c is 4 all over 2 times a. All right, so negative 2 plus or minus 4 minus 16 is negative, so that's imaginary. So that means this is going to go like this. And that is it.